Okay. So thank you, everybody, for coming here today. I know there's a lot of talks you can go to, and I appreciate you've come to ours. So today we're going to talk about AI in industry and what it means to business. And we're going to be talking about three major topics. So I'm going to open up and discuss large language models. Everybody knows about this. This is the topic. This is like ChatGPT. This is Claude. These are these things that seem like they're talked about every day, almost to the point of nauseum. And then Frankie's going to be discussing computer vision, and we're going to use it on a pretty simple task for a trained model. It's going to be PPE site safety, and that's going to be things like looking at helmets, looking at vests, things like that. We'll do a little demonstration. And then MISPA's going to be discussing broad AI ethics. So let's get started. So again, I'll be discussing large language models. I'll be talking about a contract that some of you may be familiar with, which is the NEC contract, and this will be the NEC 3, so a little bit older. This is different, of course, to the JCT contract. I'll be looking at an open source model. I'll be looking at Llama, and this is a smaller model, and I'll explain why I'll be doing that. And then we'll be talking about RAG. You might be familiar with RAG if you're really keeping up with this on something like, I guess they don't call it Twitter anymore, but and then we'll look at two different forms of that and how they're used. So please don't tell me this is an alpaca. I'm not sure which one I ended up choosing. But so again, this is just to talk about Llama. So Llama is going to be that open source model. It's smaller. This is a copy of the NEC 3 contract. I ended up making kind of some fabricated data for us to look at today. We're going to use, again, a trained open source model. And we're going to use some retrieval to work on that. So we'll talk just very briefly about the problem. So there's, of course, contract review. There's an economic incentive. Of course, we don't discuss too much about the economic incentive, but it's very expensive to have contract reviews. Legal counsel costs a lot. Of course, solicitors cost a lot to work on. At the moment, these models are not good enough to completely replace them, but we want to speed things up because we don't want them spending 20, 30 hours looking at these 70, 90-page contracts. And they're being used. UK construction, companies across the UK, from 2023, about 15%. About 15% of projects were using AI in some capacity. This is a pretty broad usage. To 75% in 2025. And then we have the problem with that is, of course, we have hallucinations. Is anyone familiar with this concept, hallucinations of AI models? It's very frustrating. You're trying to use a language model like ChatGPT or whatever, and it gives you some nonsense, but it sounds correct. It sounds plausible. And that's really what it is. It's something that sounds plausible, but it's not really tied to ground truth or reality. And in recent studies, even the most common, you may know LexisNexis and those type of, those companies that look at legal documentation, about 17 to 33% of the time, models like that are commercially available do have hallucinations. So I'm going to very briefly talk about this. You may be familiar a little bit with what this is, but really what we're looking at is a prediction machine. So we have something very simple here. The cat sat on the blank. This is a common rhyme in the training data. Very commonly comes up as mat, as opposed to floor, sofa, and so on. But what I want to get across is that language models end up looking at this not as a word itself, but they end up looking at this as a vector. So they look at it as a series of values. These are normalized from -1 to 1. And what this does is, in linear algebraic terms, it just shows a line in a multidimensional space. And here I wanted to show that you have a king and you have a queen. They're both people. They're both, royal. And the difference between the two, of course, is gender or feminineness or woman. So the expression of that semantic concept is demonstrated in the form of a line, in the form of a vector. So this brings us to retrieval. So we're trying to reduce the number of hallucinations. And the thing is, we're looking at possibly using smaller models. And the reason why is because when we use these large models and they're exposed to cloud infrastructure, so we're using ChatGPT and Claude, very often they will use that information to train their models later on. So with using a smaller model that you have on site for a company, you might be able to train it and use it in a way that you're reducing the number of hallucinations. Um, so for here, we're going to look at retrieval. So I want to give a few examples. So if you come up to a person on the road and you ask them how much is the sales price on 23 Morrison Road in Leeds, their answer might be, how should I know? Who are you? Or why are you following me? Why? Who are you? There's no context. In the case of an LLM, we might copy and paste an entire contract, so 70 to 120 pages worth of text. This might be like handing someone a contract. I might hand you a contract. And then I might have you read it. And then I take the contract back. I say, how much is the sales price on 23 Morrison Road? They might remember it. It's probably on page 2, and you've probably forgotten, so you give an estimate. We can overwhelm language models with very large context, and it causes hallucinations like this. But what we want to do is we want to ask, how much is the sales price on 23 Morrison Road? And we want to hand them the contract and have them go through it and flip through the pages and find the actual sales price. And this is what we're going to do with RAG. So the first thing we end up doing is we take the full text and we break it up into chunks. So we break it up into these subsects, these 200-word chunks. Often we include overlaps. So for this specific example, I'll be doing 200-word chunks for this model. A little bit of a formatting error here. But there are two different ways we can look for something. If I hand you a contract, I want you to look for it. Look for some type of information about sales price. Maybe this solicitor has used a different series of words to describe sales price. But being humans, of course, we have the capacity to replace words and understand the semantics. So maybe purchase value is what's used. But maybe they do just use sales price. And the thing is, we'd like to be able to use both. We don't have to choose. It's not the matrix. We can pick both of these at the same time. But the important thing is that we're using those vectors with semantic retrieval, and we're looking for very similar or a very short angle between these vectors. When we look at keywords, we are pulling this information from, of course, keywords. We're looking for words that are from the query that are unusual in the broad corpus of information in the text. And we are going to grab that chunk and include that in the context so we're not overwhelming the model. So I'll give you a brief example here. So I'm going to go and show you just a very quick model, just a quick draft of something that could be done. And so in this example, there is an uploaded PDF. We're going to drag it. You got it from DocuSign. Everybody's signed it. Hopefully we've done a review before we signed it. But in this case, you got the document as a PDF. It's being converted into text using an OCR software or a module like PyTesseract. We go ahead and we chunk for RAG into 200-word sections like we talked about. Then we're going to extract information using those two different types of retrieval. We're going to use different algorithms to pull different chunks. And remember, that's to make sure it doesn't make mistakes, or at least fewer mistakes. And then we're asked some questions. So you can ask any question. If you ask a query, it's going to be able to use two different methodologies to be able to pull chunks. So this is a video recording since I'm using Frankie's computer here. So I've gone ahead and added it. I've asked some basic questions, so you can actually program in if you have common questions or things that have burned you in the past. It can run like risk flags and things like that. Here I've included unexploded ordnance. I wanted to make sure this small model was able to determine that there were, this type of thing. We have basic contract details. It's got the price in there. Down at the very bottom left, I hope you can see, I'm going to go and type in some questions. Excuse how slow I'm typing. I'm trying to make sure you all don't see my, I type. But I'm asking a question about what are the insurance limits for third-party property damage. So when I look that up, it's doing two things. It's pulling chunks that are similar semantically, so it may not necessarily say the words property damage or this. And it's also pulling up based on keywords. It's able to pull up an answer, and it's able to describe what chunk it got it from. So it got it from the chunk that's about 401 to 600 words in. I'm going to ask another few questions. So what do who do I contact? There's a dispute. Of course, that would be an adjudicator in this scenario. And I'm hoping, the model will go ahead and pull up the name and the contact, the location of the adjudicator. And just a couple more questions. So over here again, you can set up the model to answer questions again that are common. You can set up, if you're using Python in this case, you can preset it so that way if your company is used to asking certain questions, you want to make sure someone doesn't miss a certain question. You can answer that. So you've got a general idea. You can either pull a text file in this one or upload a PDF. And this is running entirely on your computer, so you aren't putting it out into the ether. You're not putting it out to a cloud server that's going to be inevitably hacked in 6 months. So for the way that I had it set up, I just set up looking for things like asymmetric risk from one party that was too high for one party versus another, looking for vague language or missing early warnings, anomalies for payment, liability exposure, disputed comp events. So these are common things. Again, you can actually have the model look for specific things that you've had issues with in the past if you have a bad taste in your mouth about something with a specific contract or PIS documentation. So you can fine-tune models. I haven't done it specifically for this one because I do not have thousands of NEC contracts saved up or any existing outcomes from them. So this is an example. This is just a diagram. Ignore all the math on it, but this is low-rank adaptation. This is a common methodology. You can actually train the model specifically to reduce the amount of mistakes it makes on your specific task. How else are they being used for large language models? You have project planning and scheduling. There is safety management, so you can use RAG on large documentation for safety standards, which there are a lot of safety standards and legislation in the UK for construction, I found. Processing and compiling large amounts of documents, like we talked about before, very large documents. And interestingly, I didn't actually know this until doing some research, was cost estimating. I always thought this would be difficult. There was an architect I talked to in the crowd that I want to talk to afterwards about some other things, but I'm finding that it's being used in things that I wouldn't have necessarily have thought about. And they see some decent accuracy. A 61.83 doesn't sound excellent, but this is the Stone Age in AI years 2025. So thank you all very much. And Frankie's going to come up and he's going to be discussing, of course, computer vision and PPE detection.
Thanks, Ryan. So my name is Frankie. I'm a final year PhD student at University of Hull. My research revolves around improving the image generative quality of a class of generative model called diffusion models. I don't know if you're familiar about diffusion models. So Ryan gave you a broad overview of what LLMs are and how you can use it to extract relevant information from any C3 contract. I won't be adding anything to what Ryan have already said. I would be going tangent and talk about something completely different. So construction is the most dangerous sector in the UK based on the number of deaths that happen in the construction sector. So last year alone, there were 35 deaths that happened in the site, like due to fatal injuries, which is higher than agriculture, fishery, and forestry combined. And this only accounts for the fatal injuries. Now, if you were to consider the non-fatal injuries, it would go to a staggering number of 50,000 average over the last 2 years. And this graph right here gives a broad overview of what are the main causes for the serious injuries in the construction site. And if you look at the top bar, you can see 33% of the accidents happen because of the worker falling from a height, and 30% of the accidents or injuries happen because of slips, trip, or fall, and 13% of the accidents or injuries happen because of the worker being struck by moving or falling objects. I mean, I created that video using AI, so it's one example of how you can use AI. So anyway, some of these accidents, the one I showed you before, it might be linked to the workers not wearing the appropriate PPE, or human error from the supervisor failing to notice and address the non-PPE compliance. And you guys might be wondering, why am I giving you stats on the accidents and trying to raise PPE awareness when I'm here to talk about AI? The reason is because AI, or more specifically a field within AI called computer vision, can be in fact used to mitigate these accidents by training these models and using them to monitor and alert when a worker is not following the PPE compliance. So Ryan told you about LLMs. So LLM, what it does is it deals with textual and sequential data. But computer vision model, it deals with images and videos. So it basically gives a computer or a robot or a machine how to see, process images and videos and its surrounding. So computer vision is inspired by human visual cortex. So just like how we identify an object or a person by looking at a feature specific to that object or a color, the computer vision model extract relevant features that then it associate that with the object within an image or a video, which it then use to classify or detect the object. To give you a more concrete example, suppose you are in a crowd and you see someone walking towards you that looks familiar, then you would look closely for visual cues like the way he walks, his hair color or height, to identify who the person is. Just like that, a computer vision model, when you pass it an image or a video, it would look for certain features that's specific to that object, and then it would combine that to form a certain shape, which it then uses to classify the object in the image or the video. And it learns to do this after watching or seeing hundreds or even millions of images. And the models like ChatGPT, it has been trained on millions and even billions of images. That's why when you ask it to create an image, it exactly knows what are the certain features specific to an object like an apple or a person. So back when I first started learning AI, it was about 7 years ago. It was not the easiest field to break into because you need to have a very powerful hardware like a GPU, which is graphic processing unit, if you know. That's what you use for gaming and stuff. But today it's very prominent if you want to train an AI model. So back when I was learning, you need to have a powerful GPU, which costs like 2,000 or even 3,000 pounds. And you had to train a model from scratch. It would take hours or even days to train the model. And you had to train this model from scratch. What I mean is like you have to write every line of code. You need to be an expert in AI. You need to know how the different parameters work. So you need to like tweak the model so that it would learn better. So you have to be an expert in AI. You have to be an expert in a programming like Python or Rust or anything. And the last part is like it was not very easy or straightforward to test and deploy this model. But today, like the field has progressed so much, with cloud computing services like Azure, AWS, you don't need to own a powerful GPU or a hardware. You can train your model online on the cloud, and it won't even take like hours. And if you were to what I'm trying to say is like before you had to train a model from scratch, but now like researchers and companies like Llama, for example, from Meta, they've released open source model. You can take this model, which has been pre-trained on a very large data set, probably like the whole of internet when it comes to like, say, Wikipedia, the Reddit, and all the images. So this model has already learned how to learn, so to speak. So what we have to do is like take this pre-trained model and train this model on a very small subset of like maybe images or text, like Ryan was saying, fine-tuning on a contract, so it would look for a specific, it would get the context of what exactly we need from the model, right? And that, so we've got the GPUs or like the cloud computing to solve the programming, like the hardware issue. Then there is like powerful pre-training model, which avoids need for like training from scratch. And lastly, with tools like ChatGPT, Claude, or Codex, if you know about this, you don't need to be an expert in programming. You don't need to be an expert, you don't know how different AI model work or what parameters you have to change for the model to train better. You can't just ask the model in plain English what you need, what you want a model to be doing. So the model will then go and the AI tool would go and then find the right model and the data set. And then it would ask, it would even write the code for you. So you don't have to worry about be an expert in the field of AI. And lastly, these pre-trained models, they have become so efficient to the point where it's not like billions or millions of parameters. You've got really small models which you can deploy on edge devices like CCTV or a drone. So to illustrate this point, we trained a model at the University of Hull, and the first video is a video that's been recorded from a construction site, and the second video is the same video after being passed through our model. You can see the model is actually detecting the different PPE equipment. For example, in this one, the model is detecting the person is not wearing a vest. And it even detects when a person is wearing a helmet or a gloves or a vest. And if you look at the number next to the label, it's how confident the model is in its prediction. And today, for today's presentation, we wanted to take it a step further. And we want to show it to you this model can be deployed in real time, and it can be used on edge devices. So we are going to show you a live demo. And when we were testing, Ryan was our guinea pig. But today, kindly, he has agreed to be a test subject again. Thanks, Ryan. Just give me a second to set this up. Right. And then what you do so Mr. Can you give me a person
Yeah, leave us the other there.
Yeah, of course. See, my first Mr. I want to get right. So yeah. Now if I were to point the camera at Mr. Oh, you can see it's actually detecting a person and it's saying like it's not wearing, like Misbah is not wearing a helmet or a gloves. Now if Ryan were to take the stage,
Right, Mike.
yes, it's actually detecting the helmet, the vest. Maybe you can show your hand, no gloves. And it's actually doing it in real time.
Not bad. Okay.
Thanks, Ryan.
Do you work there?
No, I don't know how to get him. Yeah. I can't. How? Lucky. How sick? That's what. Yeah. Right. That was the live demo right there. So this model that we just showed you right now, this was not trained from scratch. This is a pre-trained model, or more specifically, we use YOLO, which stands for You Only Look Once. So this is a pre-trained model which has been trained on a very large data set. So I trained the model up for like 2 to 3 hours. That's all it took. And I did not train the model on a very large data set. It was like a couple of hundreds of images of different PPE equipments. And all I had to do was like take this pre-trained model, choose a very small subset of image, and train the model on that model. Train the data set on that model. And the point I'm trying to make today is like we've reached so much in the field of AI. There's so much progress being made. Anyone like here right now can train a model from for your specific task if you want to. So coming back to circles, what I said at the beginning of the slide, these models can be deployed in the construction sector to mitigate the different accidents that happen in the sector, to bring down the even deaths or minor injuries. So how we can deploy these models? So these models are very efficient to the point where you can deploy this on edge devices like camera or a CCTV or a drone. And these models can detect different events in real time, just like I showed you. For example, like non-PPE compliance or intruder or trespassing. I don't know how practical it is for a security personnel to inspect a construction site 24 hours, 7 days a week. But if you were to deploy one of these models on a drone, and if it were to sweep around the site, it can detect like any intruders or trespassing, and it can alert by sending notification to the appropriate people, then they can take action upon. And lastly, these models, like the readings and different notifications, can then be logged for future trend analysis. So I'm approaching the end of my talk, but before I'm concluding my part of the section, I want to say like every single person sitting right here today, you can be a programmer. You don't have to be an expert in a programmer. All you have to do is use tools like Claude or ChatGPT or even Codex. You can literally tell the model in plain English. Let's say you want to create a web page for yourself or a web page for your business. You can literally say to the model in plain English that this is what you want. And you can say, what's your level of programming? Maybe you're a novice, maybe you're a beginner, intermediate. Once you've done that, the model will do all the hard lifting for you. It will write the code. Maybe all you have to do is like copy and paste the code and press the run button. And once you've done that, let's say you don't like something about the web page, maybe something at the top right corner. Then again, you can literally say that in plain English to the model. It would change that for you. So I would highly encourage everyone here to give it a try. And if you want to get started, you don't know where to start. You can we are more than happy to help you out. We'll be sharing our contacts at the end of the talk, and feel free to reach out to us, and we'll be happy to help you out. So with that, I'll invite Misbah to talk about the broad ethics involved in AI, the different things you need to be looking out for, and what the field is doing to mitigate that. Thank you.
Right. Hello, everyone. Now I will move forward to the final part of our presentation, which is broad AI ethics. So far, we have seen two useful examples. One is the contract review and the other is the PP detection or construction site. So this shows that AI can support decision making, save time, and also the improved safety. So, but AI is not only the technical tool; it also has some economic effect, some environmental cost, and also the human cost. So, this section is not about saying that AI is good or bad. So, this section is more about saying that understanding the both side of it, so that we can use AI in the way that is useful, fair, and safe. Right. So this slide is focused on that how the AI changed the way we think and feel. So the one issue what I call is that yes machine problem. So AI designed to be helpful, but sometimes they can become too agreeable, right? So the source says that the AI agreed user 50% more than the human. And it might be include that the human or the user might be asking for something harmful decisions, or something might be a poor points of decision making. So this is why I think it is important to raise the second problem, which is about the dependency. So this matter because the people may start trusting AI response emotionally, not just practically. So like AI is not just a human friend, right? It's not a doctor, lawyer, or a therapist. So, but it can sometimes feel like one. So that's why the studies shows that around 40 million ChatGPT interaction found it, like where the approximately 500,000 users like depend in emotionally to the AI chatbots. So the third point is data. So where every time we interact with AI, we somehow sharing our personal information with it, or somehow we share some sensitive data with AI tools. So in that case, because this is publicly also available somehow, so this in that case, this is highly risk in the area of healthcare especially, and some hiring field as well. So this says that the slide says that around 75% of medical devices are classified as a high risk from being used in especially in the radiology field. So let's move to the next slide. So this slide is about the economic effect. So AI is changing like work, skill, and ownership. So the first question is who pay for the upskilling, right? So there are workers. The 74% of the workers says that we need to retrain our skills just to stay relevant in the field. But only 1 out of 3 employers just currently funded. So I think upscaling should not only the responsibility of the worker and only alone on the worker. It also needs like employer, university, and governments need to upskill and fund it for some training programs for it. So I think that's a good opportunity for people who wanted to upskill and stay relevant in the field, just not to be get out from the AI jobs. So yeah, so the next point is about copyright and ownership question. So there are still cases running in the court where they claim that if AI is trained on a human data, so who get that credit or benefit from, like who get payment from, so-called. So there are still ongoing cases. So still it's just legal answer is not fully settled yet. And the third point is about the productivity. So AI can help companies work faster and save time, but the important question is who get that benefit? Will the worker also benefited from? Will only the companies or big platform is getting benefit from it? Or the source says that the USA labor share, the economic has been fallen from 58 to 51% since 1980. And this gap is still like increasing. So this means the worker are raising smaller share of money being made. So AI needs to be useful and needs to be balanced in equally for the users and the laborers as well. Right. So the third ethical issue is the environmental cost. Every AI prompt, when we chat with some AI tool, we feel like, okay, so we get the answer within few seconds, right? But behind the simple that prompt or communication with AI, there are millions of data centers and some cooling systems, water consumption, and so many hardwares are being used. So the first point is that says that the source says that around 80 million tons of carbon dioxide is being used in 2025 alone, and data centers are also using the 415 terawatts of electricity by the end of this year. So this also the second point is that about discussing about the thirsty machine. Like the data center consume about 560 billion liters in 2024, and the AI water shares like around 765 liters by the end of the 25, which means that AI is not weightless. It is physically an environmental footprint as well. Also, there is e-waste. This means that AI also create pressure through hardware manufacturing and replacement. So when we talk about responsible AI, we also need to be use AI efficiently, and we need to talk about the efficient AI. Okay, so this was a little bit bad things about the AI, but it also very important to end this section with some balance. So AI has risk, but it also brings some real benefits, right? For example, AI is already being used in climate solution. For example, power grids, like optimize power grids, predict extreme weather, and accelerate material science of clean energy, right? And regulation is also catching up. It also knows that the 9 USA states have introduced AI safety law. This shows that the government are starting moving to the like a more safety and introducing some laws. So the 9 in the European Union AI Act began in enforcement in the 2025 as well, and the 9 out of the USA state is also like using these laws for using the AI. Also, if I talk about the AI safety, so it is also improving. Companies are now testing AI more carefully. They check whether AI is give harmful advice or not. So the source says that around the Claude 4 performed well on the mental health safety test, and like which called is like psychotic bench, which means that some AI system are being improved, reduce harmful or risky response. So this is important, and for the sensitive topic like mental health, and also the agree with the humor decisions. So the key closing point for this slide is that AI should be useful, fair, transparent, and sustainable. So this brings me to the end of this section. So I will call my colleague to come up to wrap up those things. Thank you.
All right. There's my clicker. Okay. All right, everybody. So to wrap things up, so I talked a little bit about some of the applications, the additional applications for AI, especially with large language models earlier. But just to talk about a few other things, I hope while you're listening to this, you're kind of thinking about how this could be applied to other things. You could think about how to be used, of course, with language models, there's convolutional networks. I guess I should call them visual models here. But how you can actually use these. So some other things might just be like meeting minutes and extraction, doing building safety case documentation I found is quite common for language models. And as Frankie was talking about earlier, with having a drone go out and maybe something like looking at facade and cladding condition surveys and looking at footfall analytics, of course, not specifically to construction, but looking instead at, a more commercial aspect of something like a mall. But, so we've talked about everything. We've talked about the NEC3, we talked about the YOLO V26 with machine vision and broad AI ethics. So I would like to invite any questions about any of that. Does this get any wheels turning about anything specific to your companies or institutions?